Hello everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We have a new member of the Handmade Hero family today, I am pleased to say. As you know, since starting the series, we have had Alan Webster create an editor that we now use on the stream, so we no longer use GNU Emacs, we use 4Coder on the stream. And it turns out that we now are able to switch over to our own drawing program as well. It's called Milton, and it's actually on the Handmade network site, much like 4Coder is. And I wish that I could pronounce, I'll tell you a little story. I won't say used to, because we probably will do more episodes in the future, but every so often, myself and Jeff Roberts, we do a podcast called The Jeff and Casey Show. And on this podcast, quite some time, I believe, before Handmade Hero even was a thing, we got an email from someone named Sergio, and I tried, we would read mail on the air, like when we receive letters to the show, we'd read them for the episodes. And it just so happened that for some reason I wanted to try and say like Sergio in like a sexy Spanish. I want to be like Sergio or something like this. And I was like, but I don't know how. I was like, I don't have any Spanish skills whatsoever. Like I have no idea how to say Sergio properly, let alone sexily. And so it was a bit of a joke at the time, but point being, that happened. Well, fast forward to after Handmade Hero, and it turns out that this paint program is actually made by the same, and I'll just say Sergio so I won't try to pronounce his name in the sexy fashion, because I have been informed that I already failed at it. But point being, if you scroll down on here, milton.handmade.network, you will get to him. Here he is. Let's say it's Sergio Gonzalez. Sergio, I don't know. You know what? Sergio, send me a wave file of you saying your name. If you want to say it sexy, you can say it sexy. If you want to just say it regular, you can say it regular. But at least it'll be pronounced correctly. And so I can finally, get past that problematic pronunciation that I did on the Jeff and Casey Show, which was horribly wrong and not sexy at all. But point being, you can go and you can check this out, this drawing program yourself. It's basically a replacement for what we have been using. It's got like infinite canvas and stuff like that, just like Mischief did. But it's actually quite a bit better than Mischief in a number of ways. Like, it automatically saves your progress and stuff, so you don't have to worry about any of that. So it kind of seems like it might actually be a little bit better than Mischief was. Much like 4Coder is turning out to be better than GNU Emacs. So upgrades all around. And point being, he did not have a Patreon when I last checked, but it looks like this is actually happening now. All right, so there is a brand new Patreon that you can support as well. I will be supporting it immediately after this. And yeah, I always try to, like any products that we use on stream, I try to put some money from the Handmade Hero Patreon over into those every month to help the folks who are making stuff that we can use. And so here is the package. Some really cool stuff about it actually is I love the old school deluxe paint interface kind of thing, where if you hit the tab key, everything goes away. I really like that. And it doesn't have the bug of Alt-Tab switching to eyedropper mode, which was a huge pain in Mischief. So already, like, this is a bit of an improvement. But there's still some kinks to work out. So we're just trying it out. We're going to try it for a while. Mostly the only thing that I noticed is the tracking speed seems a little laggy. And I think that might have something to do with... well, actually, I don't know yet. Yeah, the source code is actually available, so I was going to go take a look at it. On this particular machine, this graphics card is awfully old, too. And so, anything that's not just so may be causing it to be a little bit hiccupy. So we'll see. But as it is, it seems like it's pretty easy to do. I can go ahead and say day 277, just like before, and I can write. So, like I said, kind of cool that we're eventually switching over to all handmade stuff. And like I said, the source code to this is actually available as well, so we can actually go check it out at some point, maybe if we do a stream, and see what's happening in terms of the refresh rate on this machine. There might be some things we can do to fix it on this machine for speed, because that was the only thing that I noticed that was different. I liked everything else more, and it doesn't have that nasty bug that always kind of plagued me, which is pretty great. So there we go. So that's a new member of the team here at Handmade Hero. And so now, really, I guess we just have to figure out some way, if the debugger, if we can replace Visual Studio, we're down to almost nothing. I guess we got the compiler, but, we're getting close to no tools but the compiler, really, that aren't from the Handmade Hero community itself, which is pretty awesome, if I do say so myself. But all that being said, we still have some programming to do. That is, we've got to get down to business. And it's day 277. So if you want to follow along with the programming at home, you're going to want to unpack day 276's source code into a directory somewhere. And that will be right matching up with where I am myself. Now, what we ended on last time was we had pretty much gotten the hopping under control in terms of what I had wanted. And basically we're waiting for probably some new art. And so what we'll probably do is revisit the hopping to when we get new art, because I've kind of got it all shrunk down and scaled all weird and stuff, because that's sort of the roundness that I expect or need the art to be eventually. So like I said, that's going to be something that kind of has to get taken care of with art assets. But for now, the feel is actually feeling okay. So the actual playability of it seems pretty reasonable to me. And of course, it's hard to say that until I actually start interacting with the game proper. So we'll see how it goes. But it's at least good enough at the moment for us to for me to feel comfortable moving on to other parts of the game and bringing them up to speed. I'm pretty confident that we can make this work as it is with, with more tuning and more artwork. We can figure out a way to make that happen. All right. So, what are we going to do next? Well, I think what I would like to do next is I would like to sort of try to move the entity system and the structure of the world mode. I'd like to start trying to move those towards something more real. Like, it's always kind of been a dumping ground where we've just been like, okay, whatever we're doing, it's fine, doesn't matter. And we kind of have to sort of start making that a little bit more real. And we need to do that in two ways. One way is we have to actually upgrade sort of the logic side of that and how it's working to be a little closer to what I think is a proper system, because we've always sort of put the entity system off, and I think now is a good time to actually make it happen. So we need to do that. And then the other thing that we need to do is I would like to get the rendering under control now that I know exactly what we're going to be doing in terms of how scenes are basically as far as like layers are composited. We want to sort of go in and clean out that Z and all that sort of stuff. So I think what I'm going to do is I'm going to partition this into a couple sort of passes through the code base. The first thing that I'm going to do is I'm going to start by cleaning up the entity processing, like that whole, just the whole logic side of things. I'm going to start by doing some passes over that to sort of get that into a more reasonable place. And that includes like the storing of the, where things are stored and how they get unpacked and repacked and all those sorts of things. I want to take that and give that a good sort of once over. And then what I'd also like to do is ping pong after that over to the rendering thing and get scenes rendering properly, so that now that we know like how rooms sort of work, I want to get that sort of nailed down as well. And then we can come back and start really working on the entity stuff once that renderer part is complete. And that'll be, working on stuff like how we generate worlds and how we do AIs and that sort of thing. And just basically putting in the gameplay stuff, the kind of code that I hate, as you know, because it's really kind of arbitrary and doesn't have much to do with anything, but you kind of have to do it. So anyway, that's what I'd like to do. And so right now, I just probably want to spend some time taking stock of where things are. And I want to talk to you a little bit about sort of how I'm conceptualizing this stuff working. And it's a little bit crazy, and so I'm going to sort of tell you what my plan is going forwards. And so here it is. So in fact, I'll get some good usage out of Milton, I think, to say the least. So here's the deal. There's lots of ways you can do entity systems, right? And you know what I might do too? I might change this brush size a little bit. I don't think it needs to be quite so big. That's a little better, yeah. So there's lots of ways you can do entity systems. And to the best of my knowledge, oh wow, I didn't draw that right. To the best of my knowledge, it's really not the case that there is canonical good and bad, and that there isn't like some holy grail of entity systems that somebody figured out at some point, and if you just do it this way, everything works out great. I've never really seen that to be the case. People have arguments about these sorts of things. There's the object-oriented parts of the arguments of things, but there's also all these other sorts of things. People throw around the term entity component system. They have all these names for stuff, but really a lot of it is pretty underbaked, right? It's not like this isn't, compiler theory. This isn't something where people have really codified like what an entity system actually is, what it does, what the different ways to do it are, what the complexities of those things are. Like it's a real like black art kind of a thing. And like many things, just because people like to get into arguments about something or claim that they have a very good way of doing something, or somebody says that this is the way to do it and don't do it this way, people like to have those arguments, but only in some cases is there any actual sort of I'm looking for, actual theory or proof to back it up. A lot of times they're just kind of spouting stuff. And entity systems are pretty much that way. Now, there's been a lot of different kinds of, or ways that people write entity systems. Obviously, there's ones that look a lot like a traditional object-oriented program. And the way those work is, there might be some base class, right, that is just like, oh, these are, this is entities just in general. And then, under here, maybe we've got, orcs, right? And then we've got humans or something like this. And then under here, we've got things like, oh yeah, there's the prince, or whatever, and then there's the like, I don't know what there would be over here. There's a knight or something like that. There's the different types of things that are in here, and over here there's there's the necromancer or whatever. I don't know why there's a necromancer or something like that. But anyway, you see, there's been attempts of doing things this way, and in general, this style of sort of really, really old school object orientation for stuff, pretty much nobody thinks is a good idea anymore as far as I know, right? Like I don't see many people offering this as like a pretty good way to do things. And the reason for that is because usually in games, there are not really rigid categorizations for things. Usually the units that you create in a game or the entities that you create in a game, they borrow from lots of places, right? So, it isn't like there's all unique code in Prince, all unique code in human, and all unique code in entity, so Prince is just a Prince human entity code base, and it all just works. Like, usually that's not the case. Usually there's some stuff, for example, shared between the Necro and the Prince, right? And there's also stuff shared between, the Knight and the Necro, but that the Knight and the Prince don't share. But then there's stuff that the Prince, right? And so trying to break things into a class hierarchy often falls apart. And so, again, that's separate from, I rant about object-oriented programming all the time. That's all separate stuff. This is literally like, forget whether you're even thinking object-oriented or not. Let's just say it doesn't have anything to do with that. You're just saying I'm going to classify these things hierarchically. Just that act is kind of fraught with peril and doesn't work out particularly well. So, what people tend to do nowadays in a lot of circumstances is they sort of dispense with this kind of notion to a large extent, and instead they use sort of for lack of a better, a more compositional approach, if you will. Which is to say, okay, yeah, maybe if I'm doing object-oriented programming, so maybe I'm an object-oriented programmer and I still do a little bit of C++, or maybe you're someone like John Blow, for example, who does things this way, who isn't really much of an object-oriented programmer, doesn't super like it, but typically does like to have dispatch and stuff handled for him and a few other things like this. Maybe you get rid of all of that, but say we still have one entity-based class, but then everyone else is just a thing that comes off of that, right? There's the Necro, the Prince, and the Knight, and so on. And now what we're going to do is those things that they share, rather than before thinking of it as like, oh, a Prince and a Knight both have certain things that they share because they're human, and we'll put that in here, right? Rather than trying to do that, because it breaks down when then this guy wants to share one little piece of that but doesn't want to share the rest of it or whatever. Rather than do that, what they do is they sort of put these things inside these objects as sort of like components. So you can think of it as, I have my my struct, I guess it's struct Necro, and maybe it's got an inheritance of entity, so maybe it does pull that in. And again, that's optional. If you're not an object-oriented programmer, you wouldn't have that. If you are, you would. And then in here, you would have some things like, oh, well, my Necro uses, the burnable thing. And that's like what you need if you're going to be someone who can catch on fire, let's say, right? And so burnable is in here, and if it needs to catch on fire, then you can use this or add that to a list or, whatever you want to do, right? And so what ends up happening is rather than stuff going into inheritance, it goes into containment, right? It's like I'm constructing this thing and I put the things that I want for this guy in there, okay? That's, been certainly one way. Another way that's been looked at for these sorts of things, yet another way, is like the act-react model, which was something from Looking Glass. And this is sort of like, it parallels in a lot of ways the AOS versus SOA thing. So remember when we talked about an array of structures versus a structure of arrays? And we sort of talk about like, oh, well, okay, so a Necro, like what is that? Well, that's, like one burnable and one, health attribute or whatever, and so on. So it's got these things in it, right? It's a has-a relationship, as you would say if you were in OOP-land, right? They would do it this way, and that's very much like the array of structures method, right? So when you do things like you can imagine in vertex land, we're doing things like, okay, we've got a struct for our vertex, and then we have some real 32s in here for X, Y, Z, and W, right? And that we called array of structures because we have an array and each entry in the array is a structure containing the components that we needed, right? But when we started talking about SIMD programming, where you want to operate on all the X's at once, all the Y's at once, all the Z's at once, we sort of went into this other way of doing things SOA, which was like, okay, now instead of having like a vertex star for our vertices, instead we have a pointer for each of the different types of vertices, let's say, and maybe we don't actually really quite do it that way, but you know what I mean, conceptually speaking, where we have pointers for each of these, right? And now all the X's come together, all the Y's come together, all the Z's come together, and so I use a specific index to refer to my particular one I'm talking about, what vertex I want, but it's in a different array for each element, and that's to facilitate processing them, in bulk. Well, the act-react system is very much the analog of that. This was introduced by Looking Glass on Thief the Dark project, and that's a way of basically rotating this concept so that instead of saying I have a struct, it's got these things in it, instead I say, well, actually what we have is the burnable table, right? For everything that's burnable, has its burnable there. And then I have the health table, right? And so on. And these things get processed individually. So the burn stuff does its burning update, the health stuff does its health update, whatever. And then if I want to ask what a particular entity's state is with respect to whether it's burning or not, I look up in this table using its like entity key, whatever its ID is, right? So it's much more like a sort of multi-table database sort of a thing, the way that it's sort of conceptualized. And again, is the implementation deal this time? I'm just trying to give you sort of the broad picture, right? So there's been lots and lots and lots of ways that people have approached this problem, and you can see why it's a tricky problem. The reason it's a tricky problem is because you are inherently trying to sort of compress down the information in a very sort of flexible, broad space. Gameplay is a very flexible, broad thing. You typically want everything to be able to happen everywhere except when you don't, right? And so it's this very weird mix of like, oh, I did want that to be on fire, but not if the guy has this thing, and oh, there should be this rule that if two things are on fire next to each other, you should do this, and oh, fire affects health, and health affects fire, and, right? So you kind of have this really crazy space of just, it's whatever the human imagination that was designing the game wanted to have happen, no matter how crazy and theoretically unsound for any other particular reasons those things may be. That is nonetheless what the game design is, and you need to get it working if you would like to ship that game as opposed to some other game. So you have this very difficult problem of such a flexible, crazy, not clearly delineated set of operation that it's very, very tricky to figure out the right ways of structuring these things cleanly so that you don't have problems. Okay, so let me tell you some very basic problems that you have typically if you do lockdown sort of things in various ways. So for example, let's say I was going to do a struct necro this way, okay? It would be very, very fast to process a struct necro for any code that was specific to how a necro worked. It'd be pretty easy to write that code here because the compiler knows exactly where those things are. It doesn't have to get them from anywhere. It can just do what it needs to do, and it's nice compiled C code. It's going to be really fast, okay? But compare that to something like this, where every time I want to talk about some aspect of it, I got to go to a table, right? So I want to process necro. All right, well, to process necro, the first thing I do is look up its burnable. Second thing I have to do is look up its health, right? There's two queries right there. And then maybe I got to do even more. Who knows how many a file, an entity might have 10, 20, 30 properties that matter. It can get, there can be a lot of overhead all of a sudden in processing one of these things because I'm doing all these lookups. But because it's this general table system where you can just say, oh, does this entity have any of these things? Well, now it's completely dynamic at runtime as well, right? Like when I say necromancer, well, maybe it started out as a necromancer, but if I wanted to add some property that it didn't have before, like maybe I want to add, ballerina to it or whatever, because it's got, or like ballet state, which is the state of its like dainty dancing. All of a sudden I can, because all I have to do is, well, we know that if this is something the game understands, there'll be a balleria, that's good. Let's try that again. There'll be a balleria table, and wow, I can't spell today. Ballerina, there we go. There'll be a ballerina table, and all I have to do is just create a new record for whatever this person's key is inside that table. So I can always just dynamically add properties to any entity, and that's obviously very valuable because that adds a lot of flexibility to the game that wouldn't have been there if you had to rigidly define what these structs are. Now, maybe you don't care, right? Like maybe you're doing a game where that's just not relevant, in which case this is not a win, but you can see why it might be a win, because if you want that flexibility for things to be sort of mutable, you have that sort of need there, right? So yeah, and of course this system, I already explained the downsides of this system's just, I don't really think anyone really takes that serious anymore. But you've got systems like these sorts of things, and that's sort of one example of how those might work. Another way that those might work is you can imagine doing something, another sort of transformation on this where it's like, okay, I don't want to go this route, but I do want to have the ability to dynamically add stuff. So maybe instead of having these be wrote in here, I have like a prop list in here instead, and I just add props to this array or whatever it is, right? So all that stuff is eminently possible. There's various ways we could store it, et cetera, et cetera. So what I thought we would do on Handmade Hero, because I think this is probably one of the more interesting parts, if that makes sense, is I think we should just do a new entity system. One that, as far as I know, no one's ever done before. And that way we can sort of see, well, okay, what is it like to create one of these from scratch? What are the trade-offs? What do we do well and what don't we do well, and how did it come out? And so you can sort of see that from first principles, and I think that would be pretty cool. And since it forms the backbone of the entire game experience, it's something that's worth spending time on and worth being a major part of the development process of Handmade Hero, because it's what will drive everything in the game as far as logic is concerned, right? Okay. So I'm going to introduce this concept, and like I said, I don't know of anyone ever having done this before. That doesn't mean no one has. A lot of times in development or in programming in general, you'll find that just because you do something from scratch and you've never heard of it, and even if many people you know haven't heard of it, that doesn't mean that someone somewhere hasn't done it. Maybe they just didn't tell anyone. Or maybe you just didn't hear about it. I'm going to do something, and there are a number of reasons why this is an absolutely crazy idea, but I'm going to do it anyway. I'm going to do something I call the Sparse entity system. Oh, wow. I don't know what just happened there. Sparse entity system. And what this thing is it was my way of trying to come up with sort of a different way of looking at entities that preserved all of the speed of how you would write code in C to deal with stuff when you know what you are dealing with, but still have all the benefits of having entities that can do anything and become anything in any way, right? And so this is what I came up with, and it's kind of a crazy idea, but the only way you know whether an idea is truly crazy or not is to try it and see if it works. And if it works, it wasn't that crazy. So here's how it works. First, I would like to say a little bit about inheritance. Because there's something about inheritance that I say often and people look at me kind of funny, but it's like obviously true, I think. So I don't think it's like contentious. I think I just don't often take the time to explain it, and it's not the way people maybe think about it normally. So I'm just going to say it here, because it bears on what I'm about to say with the sparse entity system. So inheritance is this concept that if you're a C++ programmer, you've come to understand as meaning something relatively specific. And now it doesn't necessarily mean something quite that specific in the general object-oriented context, but either way, we can use this as sort of a point, something to get the point across. And what that is inheritance is sort of like saying, well, I've got this struct, right, and I'm going to call it foo. And in that struct, I have an integer x. And I know that anytime I've got this integer x, that there are some things that I might want to do on that integer x, right? So I have algorithms that depend on this integer x. And maybe to make it a little bit more realistic, typically, we're going to be bundling something. So we have an integer x, and then we've got some other thing here, which is like a Boolean. I might as well use my types, huh? S32, x, and a B32, which is like, is it fat? Is it fatty, right? Is it kind of like a bloated thing? So I've got these two pieces of information here, and then I've written these algorithms, right, that depend on those two things being together. So x and fat are both supposed to be there, and then I can write things in C. C lets me write things very cleanly in ways that understand this. So I can do something like, make a function called defatify, which takes one of these things in, right? Here's my foo. And this defatify is going to do something like if, the foo x is, less than 10, then we'll just state from now on that the fat is not fat anymore. Okay? Now again, I know this looks really simple, but I really want you to think about what is going on here, because it's very, very important. And it's the cornerstone of understanding a lot of how architecture actually works at a low level, okay? There is no difference in terms of actual what we are doing theoretically, right? Between writing defatify like this and writing defatify in the equivalent way like this. Okay? Oops. Does that make sense? Now, you can see it, how it looks there, right? And on the left side, we have something where we pass in a foo, and we're going to say if the x in the foo is less than 10, then set the fat in the foo to false. But the logic and what this function does changes not at all if I were to just pass a pointer to an x and a pointer to a fat, right? Now, what has happened when I do this operation, when I go from here to here, is I've made this function more flexible, right? Because now it can operate on any pair of x and fat instead of having to operate on ones that were right next to each other, okay? So in a sense, this is an optimization of this. It's an optimization in two ways. First, it optimizes our ability to semantically write the program, because now it takes us less time if we know that we often have x's and fats occurring together in a meaningful way. Now we can use that foo everywhere instead, which saves us typing and keeps our code more organized and reduces the errors we might make, right? But it also helps the compiler optimize, because now it knows, well, I can just pass one pointer and know that there's a fixed offset for getting from the foo, from the x and the fat, right? And so I can do less work in the resulting machine code to accomplish the same operation, okay? So this is more cumbersome and slower, potentially, right? It's both of these things, potentially, than this is. And so typically we prefer this, even though this is more powerful, right? It can do more things. Because instead of only having to call it with a foo, you can do it this way. And so this function, there'd be times when you have to bundle these things together, pass them in, and then unbundle them on the way out, right? It can't do the other operations that this can do necessarily without essentially writing all this pre and post amble. Right? Very, very obvious, like I said. There's nothing particularly interesting happening here. I just wanted to get that out so you can see that, right? So now inheritance is essentially the same sort of understanding. If I am now to say that I would like to inherit from struct foo, and I would like to make a struct bar, all right? Then obviously what I could do, with really no loss of generality or anything else, is I could just make a foo pointer here that says, well, there's a foo, right? Or better yet, I could just contain the foo entirely myself, right? And then anytime I actually want to use this foo, I just take the address of it, right? And I pass it through to the person who wants to use it, right? So I can call all the things that I would have called on bar on the foo, and that will just work, okay? Now, when I do this, I typically, presumably, want to add some more information here. So maybe I add a real 32 here, which is like, you know, squimpy. It's how squimpy the thing is, right? You know, is it particularly squimpy? I don't know. Maybe there's a 0 to 1 number that's squimpiness, right? So I'm going to add that in here. And so now what we're going to do is say, well, all right, if you look at what happens when I try to, construct this, it starts to become a little bit cumbersome for me, because now every time I have to call defatify on one of these bars, I have to take the address of the foo inside it in order to call it, right? And that's kind of annoying. So really, all I want the compiler to do here for me is just, could you do that automatically? You know that foo is the first thing in there, right? And so if you knew foo was the first thing, you could just go ahead and pass the same pointer, because a pointer to a bar and a pointer to a foo are the same thing. They always have a foo at the top, right? And so inheritance was just saying, oh, okay, well, if I have a bar, I want to be able to say that it's got a public foo inside of it, right? That's probably should be lowercase there. It's got a foo, and then I only define the new things here. Right? And now the compiler knows, oh, anytime someone was expecting one of these, I can just pass it regularly and it'll just work, so it's all good. Okay? And the reason that happened is because we preserved the condition that we needed to do the optimization just like here. We know the relative offsets of things from the base pointer, so everything can just be compiled with that knowledge in place, right? There's no difference. We could have just stuck with this, and every time we wanted to call defatify on something, pass those pointers to the actual internal parts that we care about. But it's just semantically much easier to use the inheritance way, right? And it's faster using this way because we know where everything is. And that is why, of course, the base inheritance mechanism in C++ is so rigid and is so, you might say, underpowered compared to inheritance mechanisms in other object-oriented programming languages, for example. It's because it was trying to retain this fast property of knowing where everything was relative to the base pointer. So now let's look at precisely why this starts to fall apart and what it was actually doing when it fell apart, or what it was trying to preserve when it fell apart that maybe we don't want to preserve. Well, I don't want to spoiler warning it too much on it. Let's just say, let me show you some more things. All right, so here are my structures that I was talking about. Typically, what happens now is when we start talking about this in the more realistic context, you can start to see why inheritance begins to break down a little bit in the cases that we wanted to talk about above, where we were talking about, oh, we've got burnables, we've got health, we've got those sorts of things. So now if I want to start talking about something and I wanted to create one of these structs, right? Like let's say I wanted to create one of those necros like I was talking about. Well, now I want to do some inheritance here, and I want to say, well, I want to use it with things that expect, a health thing there, right? And I also want to be able to use it with something that supports, a burnable, right? And there's all these things I might want to inherit from, okay? Because if my way of saying that I use functionality comes from inheritance, okay, I want to be able to grab all the functionality that I want. Well, this obviously starts to break down very quickly, and it's why, this is the multiple inheritance case, right? That's very terrifying to C++ programmers because it's so wacky. But you can do it. Multiple inheritance is very problematic because now you can no longer use the trick that C was using. We can't just say, well, I want to be able to pass this thing around to any function that expected one of the things that it like kind of does, it kind of looks like, right? It's a healable thing, it's a burnable thing, it's a whatever thing. I can't keep using that trick because the trick I used was to put it first. But only one thing can come first, right? And so now a pointer to a necro is no longer also a pointer to a health and a pointer to a burnable and a pointer to everything else, because only one of those is actually going to be first. So yes, passing it to a health, a thing that specs health, that may work, because that's the first thing, let's say. But passing it to a burnable, that won't work. The pointer has to be adjusted because the burnable is in a different place relative to that top necro pointer. So when pointers get passed, they have to be readjusted, right? And so now things start to break down and it starts to be a little more cumbersome, but you can do it, right? You could still do it, and you could lean on the multiple inheritance system and try to make that work. Believe me, people have done it. But now we get to the final problem, and the one that's obviously just never works in C++, and that is if we wanted to make this dynamic. If I built my whole code base around C++'s multiple inheritance, and now I want to say, oh, you know what? I created a necro. He was running around, And then he had this spell cast on him that gives him this extra property that normally he doesn't have, right? What do? I can't add new inherited things to a C++ struct at runtime, right? That's not a capability that the language allows, and for good reason. The language is a compile-time language. The inheritance is compile-time oriented. All of these things with the offsets and the pointer fix-ups that I just talked about, which have gotten much more complicated with the multiple inheritance, all get baked into the code. So now it's a non-starter. I literally can't just choose what things I want to add to it and expect those to work. And furthermore, it wouldn't even make sense because where in the code would it ever be called? There's so many reasons why that doesn't really work, right? So now comes the part about inheritance that I want to say that people don't usually understand when I say it, but I'm going to say it here. What I normally say is inheritance is compression. It's a compression algorithm. And that's it. That's all inheritance is. It's strictly a compression algorithm. It doesn't do anything else. And let me tell you what I mean by that. Let's say that I was to take every possible thing that could ever be contained in an entity, right? So let's say I've got all these properties, right? And I don't know how many there are. Let's say there's 200 of them, okay? Let's say I was to take those and just actually put them all in one big struct, right? Just they're all in there. So I just have a giant struct, and instead of trying to be clever here, I was just to say, okay, I just have one giant struct, and inside this struct is every last property that there is, all of them, right? So here's, what did I have? I had an S32 that was my X component. I had the B32 for the fat. I had that R32 for the, squimpiness? I had the squimpiness, right? So I had all of these things in here, down. Everything that could possibly occur in an entity was all in there. In fact, much like what we have going on in here where I just said, let's just stuff it in there and not care about it for now. It's just anything that anyone ever wanted is sitting there. It's giant, right? It's like a 64K structure or something. It's just huge. Well, if I had that, that could be the thing that I passed to any function. Because whatever the function was, whatever it was gonna do, it'll work. The stuff it's looking for is there. And furthermore, it's much more powerful than any of these because it can actually operate across any two pieces or more. If it wants to grab something from the health and something from the burnable, I don't need to make a health burnable class that's a thing that has member functions for those in or any of these other things. I don't need to do any of that. I can just say, hey, go look at the health and go look at the burnable. They're all right in this big struct, right? So what you're doing when you create an inheritance hierarchy in an object-oriented programming language is you're just compressing things. That's all you're doing. You're doing compression on the structs that you have by saying, instead of putting everything into one giant struct, I'm going to take just the sub-configurations that I believe actually ever get used in the program that I need to actually talk about. I'm going to take just those and make those out of the inheritance hierarchy, right? So, hey, there are some things that have an X, a fat, and a squimpy, so that's why we had a foo and a bar underneath it, right? And there's other people who need just a squimpy, so we made one of those. But there's never somebody who needs a, like a carrot top and a squimpy, so that never occurred together, and we just don't have that, right? So essentially, if you imagine all of the data, right? So if you imagine this is all the data that could possibly occur, and maybe we could even take this into the theoretical realm and just say, even if that means it is infinite, meaning it doesn't even matter how big it is, every possible configuration of stuff that could occur, we've made it so that it can all coexist together in a giant struct. If we took that and we specialized it by just picking out the combinations we actually ever use, That is what an inheritance hierarchy is doing, right? To the data. Now we can talk about dispatch is separate, and dispatch is just a function, a glorified function pointer. So hopefully there doesn't need to be too much talk about that. But that's what we're actually doing to the data. So data-wise, inheritance is just a compression algorithm. It lets you not store a ton of stuff you don't need. That is it, right? Now, this is where the sort of object-oriented programming lunacy comes in. Because a lot of people will be like, well, you know, it's good programming to like hide data that isn't necessary from other functions. Like, okay, if that's your thing, you know, go away. I don't want to hear from you. Like, go have your weird party over in La La Land. Assuming that you actually care about what the CPU is actually doing at the end of the day, the thing that inheritance actually was going to do for you was it was going to make it so that you aren't storing data that you don't actually need to store. Which isn't necessarily a waste of time, right? That's important, again, for cache concerns and all this stuff, even if we don't care because we have plenty of actual memory, which we don't always have either. You know, we care about the footprint of things. And that is what inheritance lets us do. But it comes at that very specific drawback of having a very hard time mixing things in arbitrary ways, because we have to pre-declare all the different mixed kinds that we might want. Rather than just letting them happen organically at runtime, we have to care about that, right? And now object-oriented programming languages that are dynamic and that aren't like C++ in that compile time way, they obviously take a speed hit, but they get around this problem by saying, well, we'll still keep the idea of having that sort of inheritance kind of crazy thing, but now we'll just let you decide who you derive from at runtime or do other things like that that get around that problem of having to decide everything at the outset, right? Okay. So my idea for this ridiculous entity system, that's the one that the sort of the architecture I want to try first, is to do exactly this. So what I want to do is I want to make a struct, entity, and this struct is going to be epically huge, okay? It is going to have everything in it. Like, so 64K, think, yeah, it is a 64K entity struct. Maybe more, okay? It is really, 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 really large. Epically huge. That's actually going to be what it is. And what we're going to do is we're just going to say, all right, look, we know that we can't possibly have every entity in the game taking up 64K all the time. And furthermore, we don't really want to process 64K worth of entity data all the time. But we already know that the structure of our game involves sim regions. We simulate a region where we load everything up and then we simulate it and we put it all back, right? That's already how it works. So that we can pull things into a common unified Euclidean space, do some stuff, and then put it back, right? So my idea is, well, let's make a thing that has everything in it that's the uber entity. It's an entity that has all the possible properties. It has everything. It's the most ridiculous, I think, you know, Binding of Isaac after 17 hours, and it's got all this crazy stuff on it. It can do everything. It's everything that everything could possibly be. That is what this is. And what we do is, when we go to start simulating, we do a decompress to get this entity structure, and then we do a compress when we're done. So what happens is, we decompress out of a storage, basically, our like cold storage, if you will, into our entity structure. We then compress the entity structure back out when we go to store it. And what this will be is we've got this sort of, we've got these world chunks. And what this will be is essentially a streaming system. We'll sim a bunch of entities, and then we'll go which entities fall into this, we're writing them out to a world chunk. We open up the world chunk. We write out all the entities by compressing them in, okay? And then that world chunk is closed and it's stored, right? When we then want to simulate that world chunk, we open it back up again and we decompress them out, okay? Now, what do I mean by compress and decompress? Well, I don't mean try to run like LZ on them or anything, although maybe that's a smarter way to do it. than what I'm thinking. I don't even really know. It could be that that's actually quite a good idea, for all I know, like some kind of simple compressor. And we'll see when we start testing things. What I mean is more like, and the reason I called it sparse entity is because I'm thinking more like a sparse matrix solver. So basically, this entity has a bunch, maybe it's got, 1,000 things in it, right? 1,000 properties or something. Well, what I want to do is basically just mark off which ones of them we decompressed. And then when we simulate the entity, we mark any ones that we've added, and we demark ones that we remove. And then when we compress, we only grab those ones that are actually there. Make sense? Now, you may be asking, why do this, right? Why try this? It sounds like it's strictly worse than just keeping a list of properties, sort of like this sort of a system up here that I talked about right here. Why not just put those things into a list and forego this whole sort of operation? Well, the reason is because now all of the simulation code, right? The simulation code that's going to access this, all of this simulation code just gets written in straight C style, where it knows the offsets of everything. It can be written at full speed. It does not have to do any lookups. And it has free reign to do whatever it wants. Any single piece of simulation code can pull. It doesn't have to go, oh, does it have a health property? Does it have a burnable property? Okay, well, if it has both of those properties, it doesn't have to do any of that stuff. It can just ask directly by literally looking up into the thing and just grabbing out what it is, right? That's the idea. And again, this mirrors basically what a sparse matrix solver does. A sparse matrix solver says, well, I've got this big array potentially in memory of what this matrix is, and I may actually store the whole matrix, right? Like I may say that I actually have like memory reserved for, let's say, 64,000 entries this way and 64,000 entries this way, right? But I actually only go poke in certain values and I remember where those values actually were. And then later, when I want to store this matrix out again, I just grab out just the ones that I know that I put in there, right? But because I've done that, anybody who wants to do something like, oh, what's my symmetric element, can still just do a direct lookup on the two, the M and N, the I and J indices of this matrix, can still do direct lookups and get exactly the value right back out again, right? So everything's still full speed when you're looking at the matrix itself, but when you unpack and pack it, you're only looking at those specific cherry-picked values, right? So that's the idea. And so that's what I would like to play with. I would like to make a little thing. We'll go take our world chunks. We'll actually make them do some storage. We'll have a decompress step and an entity structure, and then we'll have a compress step. And we'll have it so that there's just a giant entity thing that has every last thing that we want our entities to have. And that way, there are no limitations on what an entity can be. If you have a tree and you want it to start walking around, no problem. If somebody casts the walking thing on it, it just becomes a walking tree, because anything that you could have done, like walking or hopping or shooting or punching or jumping or anything else, they're all just properties of the same entity, and you know that they all, operate on that same struct. So it's always free to just go ahead and turn on whatever the thing is that you want on any entity ever, anywhere, right? Which basically gives us the complete flexibility to have the game design do whatever it wants, right? And I think that is really the goal of this particular part of the game. So that's what I'm going to try, and I can't say ahead of time whether it will work because I've never tried it before. I can't think of any immediate reason why it might not work, why it wouldn't work, but I can think of reasons why it might not work. For example, the traffic for this decompress compress might be too great, right? The memory footprint for storing, however many 500 of these might be too big, right? Maybe that's too much. I don't know that cache concerns are really such a big deal. They might be, I'm not sure. But since we're only touching it sparsely, it's not like we're ever actually touching the 64K unless we actually need to use all of it. There is some false sharing problems because, things are not packed tightly. So we do lose some cache throughput, but not nearly as much as you might think, because again, we're not touching the whole 64K or anything. So it's hard to say. So there definitely are reasons why I think it might not work. but nothing that's an obvious red flag where I'm like, I wouldn't try it, and so we will try it. That's about it for today. I'm glad I got that all explained. I wasn't necessarily planning on explaining that today, but now I did. It means we can start on it tomorrow, which is nice. I will see if I can go ahead and start the Q&A here. XDAFAL. Can you talk about the dynamic dispatch? Yes, I can certainly talk about the dynamic dispatch. So, what are we trying to do? I'm trying to find the place where I was running this. Okay. So what are we trying to do with dispatch? Okay, so hopefully data is the part I actually cared about. And this is the part that's relevant to this discussion. So I skipped dispatch, but I'll talk about dispatch briefly. So what dispatch is saying, okay, I want a way to associate a function with a memory location. That is essentially what dispatch is, right? Because normally what happens is the other way around. I call a function and I pass it some data. This is a case where I have some data and I want it to tell me the function. Right? That's sort of what we're talking about here. So the typical case, right, is, going back to our foos and bars. If I have a struct foo and I have a struct bar, then it's very simple for me, obviously, to write some code, and that code looks like, do foo, and it takes a foo and does something, and then I have a function that's called a do bar. And that takes us something, right? Probably make that a B. So we call these in code, and anywhere at the point where we're going to call it, it's a fixed thing, right? It's like at the point where we might call one of these, we know which one we're calling. We're calling do foo or do bar, and we're passing it a foo or a bar, right? But at some point, we may want to say, okay, instead of me telling you at this location in the call, right? So I'm at some point in the program, I call my do foo. At that point in the code, maybe I don't want to know which function I'm actually calling. I know I want to call a family of functions. I know I want to call the do family, right? I want to do something, but what I want to do is going to be based on the memory location I'm talking about. So if this memory location happens to exist over here, then I want to do one thing. If it's this other one over here, I want to do this other thing, etc., and so forth, right? And so what I will do, right, if I'm writing this myself, is I will just add a function pointer, okay? And so what I might do, and I can even say that I don't even need bar for this part of this example, is I can just say, okay, in here there's some function pointer, and the function pointer is whatever the do is for this foo. And so now I can just say, oh, all right, if I have a foo, I can type foo arrow do, and I can pass itself to it, and off I go, right? What this has now let me do is this has let me associate a function with a particular block of memory. So this storage, the actual data, now also has information about how it might be processed under certain circumstances, right? And you've seen us do this in a couple different places in Handmade Hero, actually. Well, maybe not a couple, but at least two, maybe. That's a couple. And so, once in a while you do want this. It's not as common in OOP-land, it's all over the place, right? But it's not that common really in real code. It's not super important, but there are times when it is necessary, right? Or it is appropriate. So that's what this has let me do. Now, obviously, I may want to do something where now I've got two different types, okay? They have different information in them. This one has an R32, right? Here's my value. This one has a B32, and here's my value. And so I want to now not even know which one of these two I'm talking about, right? Well, now I can actually still use this, because even if the thing was a bar and I thought it was a foo, it doesn't matter because it's the first element in the structure. I'll still call the do, and if the do happens to be a function here that takes a bar, well, it'll call the right function and it'll think it's a bar and do the right thing. So I can actually, I don't really have to do very much to make this work if I wanted to, but you get the idea. Okay. So basically at this point, once I settle on the standard of I'm going to put the function pointer at the top of the thing, then when I need to process it, I just call that function pointer. Now it's free for me to create as many of these as I want with all sorts of different data in them. And anybody who needs to invoke do on them can do so trivially, because all they do is look at the first thing in it and they invoke that on it and off they go, right? And they don't have to ever care what type they were actually handed. They know how to call that thing, right? Okay, so that's dynamic dispatch in the basic sense. Now, C++, for reasons that nobody understands, right? And I have no idea why. I wish I could go back in time or maybe ask somebody, be like, what were you thinking? They picked the worst possible way to implement this that I think anyone probably ever has. I mean, maybe you could find a language that implemented it worse than this, I don't know. But what they decided is, well, okay, this is the sort of thing that programmers will do. Programmers often will create function pointers, and they'll put function pointers into structures so that when they are going to use that structure, they can call the function pointer. Now remember, there are many, many different things we could have done here, right? And I'd like to tell you what they all are, first of all, just so you can be aware of exactly how bad C++'s implementation of it is. And this, again, has nothing to do with object-oriented programming. This is literally a problem with C++ specifically. And that is several things. I could have one structure, right? Or I can have two structures. They can have one pointer, or they could have two. Right? And maybe this guy has them as well. Okay? So we can have multiple structures. We can have multiple functions in the structures that we might call, right? Multiple, these are like methods in C++ or whatever, or member functions, I should say, right? We can have multiple of those. There's many things that we might do. What C++ decided was the only one you were ever going to get to do, because for some reason they just couldn't conceive that there were others, or they didn't know, or they had never programmed a computer before, I don't know. They decided that you only got one of these. And what it was you can have a bunch of functions in a static table, right? It's a table somewhere off in the distance. And the only thing you get is at the top of a thing, you get a pointer to one of these tables. That's it. Now, in doing that, they gave up a tremendous amount of functionality. Oh, and by the way, you don't ever get to see this pointer. Can't change it. It's not there as far as you know. Now, in choosing to implement it that way, they basically lost almost all of the power of dynamic dispatch. The actual dynamic dispatch support you get in C++ is the weakest possible dynamic dispatch you could ever imagine, right? You cannot change anything about it at runtime at all, right? So for example, if I wanted to, when I had this old way, if I implement it by hand, I can set do to whatever I want, whenever I want. I want to change this particular one, I can change it, right? Make sense? So any given object can change what its do function was at any time dynamically. That is a great feature. Gone. Completely gone in C++. Forget it. Can't have that, right? I can furthermore change things independently, right? So I could say, oh, I want to change its other pointer, but not its do pointer. So I'm going to change only one of its member functions rather than both of them, for example. That's double gone because everything's in a table in the C++ version, so I can't do that either, right? You can't touch the table pointer. And furthermore, if I did want to implement it this way, so let's say I did implement the table pointer, but at least I put the table pointer in there, then I could at least switch the type of the object between tables at runtime. I can even do that, right? Technically, I can by going around the C++ spec and not worrying about breaking stuff, because I can just go in and rewrite the table pointer manually. But technically, to the original spec of C++ when they designed it back in the day, in the 80s or whenever, you can't do any of those things. So you lose all of the power of dynamic dispatch, completely goes away in C++. You get the weakest possible kind, right? And again, what did it see? It seems like what they cared about, which is not probably what they were cognitively thinking, but it ended up being that compression is really the only thing they got. This is the most compressed way this could possibly work, really, is having the table pointer point to a static table, because then any two instances of an object don't need to have a whole table of function pointers. They each just point to that table. However, all the things you give up for that are myriad, right? It's slower because you got to double dereference everything whenever you're going to jump. It's less flexible because you can't set it per object if you want to, right? And furthermore, they made the weird decision of not letting you ever touch that table pointer, which is absolutely ridiculous, right? Now, if you don't want to expose the table pointer directly, okay, that's one thing, but at least give us some built-in functions that can switch like what's in the table or what the table's pointing to. Like that would be pretty obviously right that you would do, and they didn't even do that, right? So the C++ dynamic dispatch is a complete waste. Really, really bad. I don't know why anyone ever uses it, but for some reason they still do. So if you actually want dynamic dispatch, I highly recommend doing it this way, meaning I would just make it yourself, because it's so much more powerful and you can do so many more things with it that I don't know why the simple syntactic sugar of not having to actually put the function pointer in there doesn't seem to me to be enough of a reason to give it up. But, you know, I don't know. Different people, I guess, have different preferences. But so the dynamic dispatch that they are talking about is literally just the kind that can be derived from one of these hierarchies and that is like sort of baked at that compile time. But that is not really very useful dynamic dispatch in my mind. Dynamic dispatch is much better handled by saying, what does my program actually need from this dispatch? What matches that most directly? For example, maybe I have only one type of struct. Maybe I don't even have multiple types of structs, but I do have multiple types of operations. Well, then I want dynamic dispatch that's like a function pointer in there, right? Or a couple function pointers in there. Maybe I do have lots of different types, and maybe they all have the same kind of dispatches between them, so I'm going to use that like a table-based method, but I'd like to be able to switch them at runtime, because sometimes I want this object to have these sorts of dispatches, and sometimes I want to have these other types of dispatches, right? Then I'm going to use that table pointer scheme, right? And blah, blah, blah. And only if you're actually talking about a completely immutable, table-based, system that operates on a hierarchy would you ever use C++'s dispatch, which is never. I don't know when you use that. You don't, as far as I know. So yeah. In our system, we are not going to use dynamic dispatch probably at all. And here's why. The reason that I don't probably want to use much dynamic dispatch is because entities in our system, again, I'm going for that really rich bizarreness kind of an entity system. I don't ever want to define what an entity is. I don't want to say this entity is the hero. This entity is this type of villain. What I want to do is say this entity has this set of parameters strewn throughout the 64K thing. And when I render it, I draw from those parameters to come up with this visual representation. But at no time do I actually want to know what it is. Because if at any time I lock it down and say this is this subclass of this thing with this pointer to this function, suddenly I've lost the ability to have that fluid, weird, like mutability. And I'm going for mutability first in this one. I want everything to be missable. I want every entity in the game to be able to turn into any other type of entity. I want every property to be able to glom on to every other property. I just want it to be the complete, most flexible thing possible. And I'm willing to give up other things. I'm willing for the code to be harder to write. I'm willing for it to be difficult to debug. I'm willing for it to be slow if it has to be. I will optimize those things and work those things if I can get that sort of holy grail of everything is super weird and dynamic and changeable, right? So I want to try and do the system that way. And so, maybe there's some cases where function pointers make some sense there, but I think more likely what we'll be using is a lot of enums. And then to figure out what we're going to do, we'll look at a couple different enums and say, what type of walking does this entity do? Oh, it's this. And like, what type of this is do? Okay, like, grab those together and then say, oh, then I'll probably, I should draw some legs on him here, or maybe I should do this, right? And so I want to kind of make it so that it can look at multiple things, whereas a function pointer, you don't usually test function pointers. I mean, I guess you could, but it's more like I want to take multiple pieces of information and use that to synthesize who we call. And so that's going to be more logic-based and probably less function point-based. Popcorn, do you use the struct entry method in your current game? My current game does not have any entities. Gotta scroll down to the Q colons. SSS McGrath, have you seen my pseudo-hacked discriminated union inheritance system that I use in my game on stream? It's pretty cool. No, I haven't. But I like discriminated unions, as you can tell from the fact that like 99% of the things in Handmade here are discriminated unions. So I'm probably in favor of whatever it is you're doing, but I don't know what it is at the moment. But I would probably like it, I guess is what I'm saying. What made you choose this approach over an AOS style plus storing indices of each separate component in the main entity struct? Okay, so basically the reason that I didn't want to do that is because I want all of the code to have hardwired offsets. Like I want it to just be straight C code, fully optimizable by the compiler to just go in and grab what it needs and do its stuff on a flat piece of memory always, if that makes sense. Dude in basement, I missed it. What about the matrix IJ? I was confused there. So what I was saying there is that it's essentially like if you think of how matrix operations work, a lot of times matrix operations need to look at particular elements like what's one above me or what's my reflected element in this matrix, right? And if you have sparse storage for your matrix that just says where those things are, then either you have to constantly do lookups in there, or you have to scan, one or the other, and they're both very slow. So instead, sometimes what you would do in the old days, and this is less true potentially now, but what you do in the old days is you would just say, oh, I'll just make a big block of memory, and I'll put things in there, and I'll basically like initialize it all to 0 once, and then all the operations I do, I'll just put things in there, and then remember to take them back out again when I'm done, so that I can always do direct lookups, right? It's kind of like a perfect hash table for the matrix entries in that sense. Parsnip, how and where would you go about checking if a property existed on your megastruct whenever you want to do your operations? Would they all be null pointers undefined? So there's none of them are pointers. It's actually the data for the property. So all the data is actually in there. And they're all just initialized to their this thing isn't happening state. So if it's like how on fire am I, it's 0, right? And so then when you go to ask how much fire is there, you always get back the answer, whether it's on fire or not, it's got a value in there that says that, if that makes sense. T-Terrace, what are you going to use to track which struct members have been touched / set back to null? To be honest, I'm not sure yet. I need to do some testing. Probably during development, depending on the speed of it, I may not. Meaning I may just always actually scan. So you just actually walk the full 64K, which is going to be slow, right? Or, I mean, I don't know if it's going to be slow because computers are so fast these days. It's going to be slower than it would be. And then when we sort of get further down and we're worried about potentially optimizing things, then I will think about, based on what we have, how I want to go about making it so that we track. Jesse Meyer, what portions of this design could you foresee causing perf issues? Well, like I said, the false sharing is probably the single biggest concern. And what I mean by that is, you know, if well, let's start with this. So basically, you can think of a struct as being broken up into 64-byte chunks. Okay, so here's my struct entity. And then we start listing the members in here, and I'm just going to make stuff up. But let's say I've got, you know, a v3 position, right? And I've got an R32 alpha, I don't know why, right? And an R32, you know, movement T or whatever. And as you start to add these up, right, you start to get a sense of how big they are, right? This is 4 bytes. This is 3 times 4 bytes, right? So that's 16 bytes right there. And so then, you know, you can imagine if this is 16 bytes here, imagine some other blocks here. Here's another 16, and maybe here's 32 bytes. So here's a 64-byte chunk, okay? And then after that's another 64-byte chunk. Maybe there's, I don't know why, there's a name field here that's 16 bytes long. I don't know why we would have that, but we do all of a sudden, and then we have like a bitmap ID, and that's more. So we just have, imagine just lots of 64-byte chunks, okay? That is how the cache, to a first approximation, sees this entity, right? Now, there's all sorts of things like aliasing and all. There's a whole host of issues that are like super complicated, crazy things. But to a first approximation, if you want to know how cache-friendly this entity is, that's what you're thinking about. Inside every block of 64 bytes, if we are to touch one of these during processing, we have to bring all 64 bytes into the cache. Right? So if I want just the T value, and that's all I use in this particular entity, none of these other things are valid. Now, why that would be, I have no idea, because obviously the P is going to be valid and blah, blah, blah. But pretend that was true, right? All I wanted to touch was this T. Well, that's 4 bytes. But I actually had to touch 60 extra bytes that I didn't use. So what that means is, depending on how our struct is organized, and depending on how the sparseness works out, and depending, we could have a lot of extra memory bandwidth getting used that is not actually doing anything, right? It's wasted. And so it's a gamble, right? You don't know. Maybe that's okay, because most of the time you are able to pack things well that they happen to work out so you don't waste too much memory. Maybe it's horrific and you're oftentimes getting into this sort of nightmare scenario. It's really hard to say. And so that's certainly one huge reason why I don't think it's a slam dunk of an idea by any stretch of the imagination, because it's like, well, there's a pretty clear reason why, you know, this could be bad. Fortunately, it's the kind of could be bad thing that is not super dangerous, because entity processing in this way, you know, how many entities are there going to be? Well, there's not going to be 100,000 entities on the screen. And this is processing for the things that we actually see and immediately around it, right? So we don't have to worry about processing 100,000 entities at 60 frames a second, right? But we probably have to worry about processing like 300 entities at 60 frames a second, maybe, right? Or at least 30 frames a second. So, you know, it's still a lot of, it's not so few. You know, there's certain games that have, so, you know, let's say it was Street Fighter, right? Well, there's like 2, you know, maybe well, it's more than 2, but, you know, how many entities are there really going to be? 10, 20? Not very many. So you just wouldn't care. It would not matter. But, you know, as that number gets up to a couple hundred, or even if it's 1,000, right, you're starting to get a little nervous, because now it's like, well, if I blow half, 2/3 of my memory bandwidth there, pulling these things in, it's kind of uncomfortable potentially, right? So I don't know. So we'll see. We'll see. I don't think it's dangerous enough that I don't want to try it, but it's definitely not safe enough that I'm comfortable saying, oh, it won't be any problem, don't worry about it. Like, no, we won't have to worry at all. It'll be great. You know, it could still go wrong. Connor Rents, what are some alternatives to an entity system? Well, there is really no alternative to an entity system if the game has entities, in the sense that no matter how non-systemy it is, you still have one. I mean, if you went back to maybe Pac-Man or something like this, then you could say, well, there's no entity system, right? There's just some specific code where you've got an array of like 4 ghosts, and you are going to do a specific thing to each one of them, and each ghost has a certain thing. You can still call that an entity system, right? And it has 2 types, Ghost and Pac-Man or whatever, right? Or, those sorts of things. So, any action game like that has an entity system because it is inherently about a bunch of discrete things that, shoot at each other or touch each other and do something. And so pretty much the basis of any traditional action game in that sense is going to be an entity system. Now, if you're doing something else, right? Maybe you're doing something like a walking simulator where nothing happens, right? It's called Nothing Happens the Game, which there are a lot of on Steam. Maybe you don't need one because maybe it's about something else, and so really there's just a huge static world and you don't ever have this notion of entities. That's not a thing, right? Or maybe you're making a game like we are 1935 at Molly Rocket. It's, it looks and plays kind of like a movie, and your interaction is about interacting with the dialogue. Well, entities aren't a thing anymore, right? It's not we don't do collision detection to find out if 2 entities interacted with each other, and like none of that is happening. It's about, a very different thing. So you can see why that would be presumably, not necessary in certain titles. Alan Webster, are you already thinking of a backup plan for the entities and how you would transition to that system if you had to? No, because, typically speaking, whatever we write, if there is a problem with it, we will see that problem occur and have a measure of it, like if it's the cache problem or if it's something else. And what the problem is and where it's occurring will presumably drive our solution in how we will modify the system to avoid that, right? So, it's, like I said, we're not going for super high throughput here. This game is not about processing as many entities as possible, so I'm not really that worried that we wouldn't be able to solve it at all with something in the ballpark of this, right? But what it will exactly look like by the end, I don't know, because I just don't know exactly how some of those trade-offs will play out. So. Alright, looks like we're done. Do I play Street Fighter? Who is your favorite character? No, I do not play Street Fighter. I was always a Mortal Kombat guy. I really liked Mortal Kombat 1. I've never liked any of the subsequent Mortal Kombats, although I only played 2 and 3 or something. I never played any beyond that, so I don't know. But I really, really liked the original Mortal Kombat. I never really liked the original Street Fighter, or Street Fighter 2, or any of the subsequent follow-ons. What it is really is I don't like animation pause. I can't handle it. I can't handle animation pause. When somebody like uppercuts somebody and it freezes and then it continues. I having that in a fighting game ruins a fighting game. I can't play it. So it was always a bit of a rough thing for me, and I just didn't like the feel of Street Fighter for whatever reason. So I couldn't get into it, which is too bad because that was the more popular one. So we used to play at the arcades. I used to like playing, versus other people, and I used to play against other people on Mortal Kombat 1 all the time, but there just weren't enough people. It was very easy in my hometown and surrounding areas to be the best person at Mortal Kombat 1, let me tell you that right now. Whereas it probably would not have been as easy to be the best Street Fighter, I'm guessing, because more people would have been playing that. Will the entity system include things such as particle effects? No, particle effects are a graphical effect that typically get launched. So the entity system would spawn particle effects, but it's not going to process them because they're very specialized and designed for very high throughput, and they typically don't have mutable properties like that. It's like, okay, if this is a thing that like spawns some fire, then the fire just particles spawn up. It doesn't those don't change to water in like of their own accord. Somebody like reaches in from somewhere else and makes that change, right? Do you play Bomberman? These are not on topic, people. You can't stand the Street Fighter pause, but you like the Mortal Kombat rotoscope. No, I didn't like the Mortal Kombat rotoscope either. Well, first of all, it's not rotoscope. It's actually just video. But I like the fact that it doesn't pause, right? Because that affects the feel. The look is separate from the feel, right? And I don't like the look of either game. I think both games are not good looking, really. But if I had to pick one, obviously Street Fighter's better looking than Mortal Kombat, I think, certainly. But I don't really like the look of either, but I like the feel of Mortal Kombat better because it doesn't have that pause. I could never get past that pause. Drove me nuts. So yeah. Oh, and as far as I'm just grabbing a thing. I know this wasn't a question, but someone was saying it does seem unlikely that you get 300 entities needing 60 frames a second simulation. And it's yes and no, because again, the whole world in this game is kind of made out of entities in some sense. Like each ground element will be an entity. So if there's let's say that we're doing a 17:9 tile, well, there's going to be something like, if there's 2 entities on every tile, the tile itself and then something standing on it, well, that's 306 entities right there, right? And maybe they've each got a bullet. So, I could see 600 entities being a reasonable entity load for this game, and I wouldn't want to necessarily say that we shouldn't have that many, that that's too many. So I would say, like, I will probably want to stress test this with 1,000 entities at 60 frames a second. So, if we're talking about, 60,000 entities or something like that, then doing the back of the envelope, like 3 times 1,000 times 1,000 times 1,000. So let's say it's a 3 gigahertz machine or something, and I want 60 frames a second, and I want to have 1,000 entities. That's not very many cycles. Right? That's just not that many cycles. Now, thankfully, I've got multiple cores to play with potentially, but still, it's something to be nervous about, I guess is what I would say. Since this is GPU accelerated, we don't have a lot of work to do graphics-wise, so that's good. But 50,000 cycles per entity is not a abundance, right? It's not like so much that you'd never be worried about anything going wrong in it. So, yeah. We'll see. We'll see what happens. All right. So my understanding is I don't actually have to do anything here because this actually just saves itself, which is kind of awesome. So I'm going to go ahead and close these guys down. And let's see here. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order it on handmadehero.org using this handy dandy button, and it comes with the source code so you can play around with it yourself. We also have a forum site you can go to if you want to ask questions. We have a Patreon page you can use if you want to support the video series, and we have a schedule bot which will announce the schedule so that if you're trying to catch the series live, you know when it is. Finally, we have a episode guide if you're trying to catch up with videos in the series from the past. That is a great place to go and check those out. That is about it. That is it for today. I will be back here tomorrow, 5 p.m. Pacific Daylight Time, and we'll start taking a look probably at implementing the entity system exactly the way that I just said it, and seeing how that starts to shake out. That's it for me. Have fun programming, everyone, and I'll see you guys on the internet.